Hi, and welcome to video 4 of gradient descent for linear regression. Alright, so if you've been through the previous videos, we got to the point of actually plotting our costs and getting to our best theta that we can use to predict a value. Now what we'd like to do is to go and predict a value against our data set. So what we want to do is go and predict number for 6 being our feature variables, and we want to see a result come out at 9, and then that would make sense. So firstly, what I'll do is P for predict, and it's going to equal, okay, it'll be 6, 6, 6. All right. So once we've got that, we now need to normalize this, because you can see as we know, our x numbers at least. Let's just go down here. Okay, we know that these numbers are normalized, so we want to normalize this number as well, so that the best possible theta that we got will actually make sense as well. All right, so if we go down here, let's go through a normalization. So we know that our normalization from the first video is x minus max divided by max minus min. So we should be able to go through the same thing over here. So let's do it down here first. So let's say P equals that value over there. So now if we want to normalize this, we've got 6, 6 and 6 and down that side there. And if we go through to our maxes and mins, let's just go down to our maxes, 5, 5, 5, and our mins, okay, is 1, 1, 1. So the first problem we've got is that this is a matrix, a one-column matrix, whereas this is a vector. All right, so what we shall do now, okay, so as I put in the function here, we'll then figure it out. So if we go P in for normalized, what we can say is we know that our formula, so I'm just going to put it in that way. So it will be P. Now what we want to do is minus the maxes. So let's just have a look at this. So we've got P and we've got maxes, but we know that we need to transpose the maxes. So let's have a look at that. We should, I think, end up with 1, because 6 minus the maxes is 5. And there we go, we end up with 1. Then we want to do maxes, and again transpose it, minus mins, and again transpose it back into a vector, and that should be, the max is 5, minus 1 should be 4, and great, we end up with 4 there. Okay, now when we divide, just remember that we want to divide row by row, so let's have a look at this one again. So I want to take that and I want to divide it by the results here, but I want to do it row by row, eh? So it's 1 divided by 4, 1 divided by 4, and then that one. So I don't just want to do a normal divide. I want to put the dot in there that it must go row by row. Otherwise it'll do normal matrix division, which will come up with a different result. So let's go and grab that. And I guess we should come up, let's just have a look here. We should come up with the answer of, I think our normalization over here was 1. So over here or 0, sorry, 0. So we should come up with 0.25, which is what we came up with. Great, so we're happy with our normalization of the prediction result. So let's go back there. Okay, so that's all looking good. Now what we want to do is just run our straight hypothesis on it. And we know our straight hypothesis is normally just our x's times the thetas. So result. Okay, so once I've got my normalized value, I just need to add a 1 onto it. Do you remember we did that up here with our training set? So we need to do the same thing over here. So we're just going to say Pn equals, and we're just going to make it an array, 1 with our Pn. Great, so let's just go and if we copy that code and put it down here, whoops, let's just do it without that. There we go, and hang on a second, I've already put a 1 on the end of it, so let me just do that. And okay, looks like I've gone and mucked that up. So what I'm going to do is just, let's rerun this. And if I have a look at P now, great, there it is. Okay, now remember, this is like our X data, like our number of features. So the problem is we don't want it here as a bunch of rows. We need it as a slice, because this has to relate to, similar to XO. What we're trying to do is get a row like that. So if we have a look over here at where's Pn, all right, Pn, we can transpose it, and that puts it into a row like that. So to get our hypothesis function over here, our theta 0 plus theta 1x plus theta 2x2, etc., we can actually then just go and say Pn transposed times, okay, and we want to pick up our best theta from gradient descent, and we should come up with a result of 9. There we go. So it fits in perfectly. 6's will end up with a 9. So let's just go and do that over here. And let's say, I'm just going to say Pn transposed times best. Okay, and for our case, we're just going to print it out. We won't set it to any particular value. Sorry, result equals. Okay, and there we go. There is our result. In fact, if I take the semicolon out, then it should print it for us. Okay, good show. So now what we're going to do is, we've done this now with our small data set, and in our final lesson, we're going to take a bigger data set that's actually got more features, and then we'll try the same gradient descent there and see if we can predict a result.